Matching the correct battery inverter for a grid-connected application will typically be based on two criteria. Either the inverter is required to have a backup functionality to power loads during an outage, or the system will be required to operate to maximise the site's self-consumption. In some cases, both criteria may be required as a function of the design brief. As a result, the required inverter criteria should be determined before selecting the equipment. For backup operations, a multi-mode inverter will be required, although to achieve an offset function only, it is not necessary. It should be noted that most inverter manufacturers do not label their equipment as multi-mode. Therefore, this functionality will need to be determined from the equipment datasheet. A multi-mode inverter that is required to operate during a grid outage will be selected based on the greater value of either the load assessment's continuous or peak power requirements. The inverter should be sized slightly higher than the power requirements of the load assessment to ensure operation, as a result of derating factors and to prevent nuisance tripping during general operation. The rule of thumb is to oversize the inverter by 1.2 times larger than the highest continuous or peak demand. For backup functionality, the inverter sizing is critical and must be sized to meet the full load demand under all conditions. There are many hybrid inverters that have a relatively low backup power capability when operating in backup or emergency supply mode. This can also be further limited by the battery capacity output rating depending on the battery size used. There are several high-end inverter chargers that provide a relatively high backup output power if required. For battery systems that assist in maximising the site's self-consumption with no backup requirements, the inverter should only be sized to meet the continuous supply. In these cases, there is no benefit in meeting the peak power ratings of the site, as this is supplied from the grid to reduce stress on the batteries and prolong its operating life. As a result of this, there is little need to oversize the inverter, as it operates in parallel with the grid. It's important to note that the surge rating cost per kilowatt hour on most domestic sites is insignificant when considering a flat tariff rate, whereas on a commercial or industrial site, this peak could be costly, and the battery system may need to operate to reduce this.